Alright, so I spoke with a couple of you about the titration problem. I seem to still be having a little bit of an issue with it, so I typed it out here, and I'm going to work through it real quick so that you have it as you work through this problem again and additional practice problems. But the question said that 15.25 milliliters of a 0.25 molar NaOH solution were required to neutralize 25 milliliters of an unknown HCl solution. What is the concentration of the HCl solution? And if you remember, we can't solve a titration problem. A titration is a chemical reaction. All right, and so the thing that's got to guide us first, our step one, is the balanced chemical equation. Let's see if I can get it to work here. All right, so the first thing that we had to do was write the balanced chemical equation. All right, because it's not always going to be a 1-to-1 ratio. In this case it is, but not always. All right, so I've got NaOH, an NaOH solution. All right, it says I'm using it to neutralize or react with an HCl solution. Okay, and I got to know that when I do that, I'm reacting an acid with a hydroxide base, so I'll get a salt, in this case sodium chloride, and water. All right, and then I would need to make sure it's balanced. Okay, but it is here. All right, and notice that it's a 1-to-1 ratio of acid to base, or base to acid. All right, now that I've got that, the second thing I'm going to do is I'm going to determine the moles reacted / required of the known solution. Okay, I'm going to do that using the molarity equation. All right, so my known solution here is sodium hydroxide. I like to make a table where I write molarity, I write moles, and I write volume. I fill in what I can. The concentration of the sodium hydroxide is 0.25 molar. The volume that I used is 15.25 milliliters, or 0.01525 liters. And hopefully you can see that when I write that out, that I've got two of the three things in my molarity equation, because molarity equals moles over volume, or liters of solution. I can multiply both sides by volume and solve for moles. So moles here is going to be equal to the concentration, which I know, times the volume, which I know. So putting that in, 0.25 molar times 0.01525 liters. And let me find my calculator. Give me just a second. I'll talk and ramble while I punch. All right, it looks like 0.0038 moles of NaOH. What that means is that many moles of sodium hydroxide were necessary to react with the moles of HCl present. And now that I've got that, the third thing that I can do is determine moles of unknown. All right, in this case that's HCl, all right, present by mole to mole conversion. Anytime I go from moles of one thing to moles of another, I've got to go through my balanced chemical equation. My molar ratio, which we set up there, is 1-to-1. I'm going to write it out anyway, because if it's not 1-to-1 and you don't write it out, you will get the problem wrong. So I'm going to take that 0.038, well, 2 zeros, I'm sorry, 0.038 moles of NaOH. and I'm going to say 1 mole of NaOH is equivalent, in this case, to 1 mole HCl. I get those ones, or I get that ratio from the balanced chemical equation. Moles of NaOH cancel out, do the math. That 0.0038 moles of sodium hydroxide reacted with 0.0038 moles of HCl. So now I know how many moles of HCl were present in my unknown solution. So the last thing that I do, let's see here, is I determine concentration of unknown using molarity equation. So again, I'm going to make a table for HCl, molarity, moles, and volume. Well, I know now that there are 0.0038 moles present in, it told me in the problem, 25 milliliters of HCl solution, which is 0.025 liters. So now hopefully you can see I've got 2 of the 3 things in my molarity equation, so I can plug in and solve. Molarity, or concentration, of my HCl is moles over volume in liters. All right, and when I do that math, I get 0.15 molar. That is the concentration of that unknown HCl solution. All right, these 4 steps, this 4-step process is what you need to do anytime you work a titration problem. Write the balanced chemical equation so that you know your molar ratio of acid to base. Solve for the moles of the known solution. Use that to convert to moles of unknown, and then use the molarity equation to solve for the final answer.